Hello. So the issues that have been presented on excercism recently include this hello world issue, which is like super easy, the Armstrong numbers. So what's the issue here? They're telling you, well, an Armstrong number is a number that is the sum of its own digits. So essentially it involves taking a number and then converting it into its own digits. Then you can sum the digits, raise the digits to a power, count the number of digits. So I think in C++ there is probably multiple ways of doing this. So here, and also I guess if statement is necessary because they want to be able to tell if it is or if it isn't. I guess we return true or false. So let's try some ideas here. So let's say you have a function that takes a number n and oh goodness, like here, okay. And then here we can take the number and then convert it to a string. So we're gonna do this by converting it to string. And then now that it's a string, then now everything is super easy because I can have the length, and this can be the power, and then I can, for example, for each one of the elements of this string representation of the number, then we can take the number and then convert it, the string representation of the digits, and then convert it back into a number, then raise it to the power of the of this power thing that we're supposed to do. And then I think we're supposed to sum it, so I'm just gonna go ahead and say our s equals 0, and then s plus equals this thing, and then return s. So we can try the examples here, like 9. Let's try 9. 9 returns 9. Oh, we are supposed to return if the number is equal to the sum. Okay, so maybe we can try s equals n. How's that? So now it returns true. That makes more sense. Let's try 10. 10 returns false. 153 returns true. Ha! 154 false. Well, so coincidentally, it looks like the function kind of behaves like what they want. However, there is the issue of converting this thing to C++. So for that, I'm going to use Xcode. Xcode. Okay. So I'm just gonna start a small little project. And what I'm gonna show here is like, what's the process of like, I guess, Googling through the solution. Okay. So yeah, let's just come. Apologies for any misspellings. I don't know how to spell either. Okay. So on this screen, we can see there is a UI that lets us run the C++ code, so we can press play to run it, and this is basically going to provide some results here. What do you call this? Like here on the bottom. So if I change this text, press play, wait a few milliseconds, and then I get the result. So bad thing about it is I cannot save Alt-Tab F5 like in JavaScript. Good thing about it is that I get compilation checking, so if I make a mistake, then the compiler will tell me like this is what they wanted. The compiler is very good at figuring out what I did wrong. So here the problem then becomes, well, how do you port this thing from JavaScript or like whatever language into C++? Well, one way of doing it is to use the JavaScript isms that we had here. Oh, he doesn't like my code at all, right? But that was kind of like what I was expecting, right? So let's pretend for a moment we have zero idea about the C++ syntax, and let's just go Google things. Like, I have this function thing, so he doesn't like it. So I guess what I will probably Google is like C++ function definition example. How do you define a function? And then you go through the page, you go to emotions, they tell you, well, there is a return type, a function name, a parameter list. Well, that's kind of abstract. Doesn't really look like code. So I guess, oh, great, an example. So you have int something. So I guess, yeah, we can just make a int, and then this function name, we're gonna call it arm, so that's a good name. And then these parameters also need type, so I guess I'll just provide a type. So, well, this line 10 looks like it's good. Now here we have this number that we need to convert it to string, but I don't know how to do that, so I will just Google number to string in C++. And here it's probably gonna tell me, well, how do you do that? Say C++ has S to I. That's pretty cool. I didn't know this was a thing. So you include string. Yeah, I can do that. I'll just go ahead and include the string. And then here's telling me you take toString, the number, and that's gonna give me an Std string. Well, that's that's pretty cool. So let's just take this expression here. Let's rename it to Sn. So string, just call it Sn. What's that? So here what I mean to say is that Sn equals Std string of n. So maybe that's better. But then I don't know how to get the length of a string in C++. So let's try a string length C++. And I guess I want the Std string length. And sure enough, they're telling me there is a method called length. Well, okay, let's see the code. Here you go. So you have a Std string, and you see how the length. Oh, it's a method. Oh, okay, so it's a little different. So let's try this. And I'm guessing this var thing is not gonna work, but I guess I meant int here. This var s, I guess it should be like int s, maybe, these integers. Implicit conversion loses precision. Oh goodness. So it can either be unsigned long to int. Well, I guess he wants to make an unsigned long, so I guess let's do with unsigned long, whatever the compiler wants. I'm just here to make the compiler happy, guys. That's literally my only thing. So if I can make the compiler happy, then I feel I've done my job. So here bar d of sn. So here I'm just trying to iterate upon all the characters of the string. So I guess let's go to iterate over all the characters of a std string. So let's check it out. How do you do that? Well, so this looks like C++. I'm gonna say 11 kind of looking code. Oh, this looks a lot better. So looks like a C++ 17. Yeah, so you have char const ampersand c. That's a character. It comes from a string. This takes a string. You know what? I think this is awesome. I'm gonna copy paste it. Looks like C++ is now way easier than what it used to be back in the day. So let's just go ahead and remove these things here. I guess we're going to character d of sn, and then you do the thing. And it turns out I don't know how to do math. Pow. Well, I mean, well, we don't know how to do math. Pow. That's fine. We can Google it. So let's try math. Pow in C++. So, what's the big idea of this video? Well, if you know one language, you can search the stuff you know in a new language. So let's try in this. Well, this function pow. This function is defined in CMath. So okay, so that's pretty useful. Can I see an example? Right. Well, so here's my example. You include math, and then you use the pow. Well, I mean, this looks very easy. Although maybe you have floats. Haha. So things become interesting here because if this is a float and I have a bunch of hints, then I'm gonna need a, I guess into float will just automatically happen, but then float back to int, then that's not gonna happen. So I guess let's just try using floats or doubles. How's that? Yeah, double. That's better, more, it has more punch to it. So let's try here. We just include this math thing here. Oh, I like this comment here. It's telling me I'm including math because I need pow. I kind of like that. You know, I'm gonna keep that idea. So here we go. Char const d, and then we're gonna pow, and then we need to pass these two parameters. And this parsing, well, so we have a character. We need to convert a character to a number. And we know the ASCII character, like we know the ASCII table. We know this character to have a numeric value, and it's probably gonna be between 0 and 9, right? So here, if we refer to trusty ASCII table, so the first number is the decimal value, so 48, that will be the number that is represented by character 0 in ASCII. And I think it's a fair assumption that we're going to be in an ASCII system, unless we are so unfortunate that we're not. And I guess what we can do is just subtract 48 from this value to get the character value. So let's try, just go and say, well, so we have this char const d. So I guess I'm gonna have this guy that's just gonna be 48 minus the d. But this can be confusing. Like, people are gonna read this code and gonna be like, okay, why is 48 there, right? So what I'm gonna do is I'm gonna put the 0 character, right? And here I'm just gonna make an integer. So let's just call this guy what's a good number? Like a digit. Let's call it I digit, for in digit. And then this guy, that's gonna be the char digit. Yeah, okay. So it turns out I have my I digit and I have my char digit. So I think this is more readable. We'll see. And then let's try digit. Well, so spaces around operators always. So the sum is the sum, and now here we are checking if this double value is equal to this not double value, and I have a feeling that maybe that will cast the double back into an int, potentially making it lose precision. So I guess that we need to do double to int in C++. Right. So it turns out you can cast it. Right. Okay. Well, I guess if I get an integer, we do this operation in an integer, most likely we'll get an integer. But I want to explicitly cast it so that the user knows that I know that I'm losing precision here. Not because the compiler doesn't do it for me, but because I want the reader to understand that I understand that I'm losing precision. And I guess we want to return a Boolean result. So in order to have a list of data types, we can search C++ data type list. Surely there is a list of data types somewhere. Oh, Geeks for Geeks. Oh, this website is awesome. I love this website. So they have like every tutorial ever. So I think it's just a bunch of Indians teaching each other. Right, so apparently it's called Boolean. Well, that's amazing. But like, what's it called? Like exactly. So I don't see. Okay, so what do we call the Boolean that type? All right. Well, just go bool. Okay. Well, then that's perfect. So let's try here and say bool. And here they want a semicolon. We give it the semicolon. And maybe it compiles. So let's call the function. So let's try run this Armstrong function on the number 9. And I guess we want to test a bunch of numbers. So let's try 9, let's try 10, let's try 153, let's try 154. Yeah, should be good. 10, 153, 154. I guess I don't need these two ones after all. Maybe we can make a for loop later. Like, yeah, we should totally make a for loop later. Let's try and see how this works. Okay, so 9 is 0, 10 is 0. Okay, so it's really lame results here. So that's interesting. But why? What might be causing this? Well, maybe this is never true. So we can just try print the S, then N. Maybe we should print like a space in between them. And like, you know, like a line break. So we can see the comparison between the numbers. Oh, it doesn't like cout. Okay, let's try std cout. Okay, so minus 9 to 9, 1 to 10, minus 153. So all these minuses. Minus. That's... Oh, I get it. This is a negative number because this guy is always greater than 0. Oh, you guys were probably yelling at the screen all the time. Oh no, you made a mistake. Right, so I guess what I meant by this conversion is just basically just have this. This 48, so I guess 48 in ASCII, right? So let's try click play. And sure enough, now it's 1, now it's 0, now it's 1, now it's 153. Right, so it is possible that we will have made a mistake where this code wouldn't have worked like immediately. So in those cases, what I do is I just press this button here that creates a breakpoint, and I just press play, and that brings me all the way to the breakpoint. And in those cases, you can see here in the bottom left, I don't know how well you can see it, but there is all the local variables and the values. So I can just tell it to just go into the function. And here, if I go into the function, now, thankfully, C++ thinks, okay, your problem is probably not in the standard library, so we're not going to go through those. So it looks like we have a double S equals 2 point something. That just means this memory is garbage, but it's because it hasn't been initialized yet. So let's just go in. Okay, now it's 0. That's good news. So here is going through the first digit. So the you can see the char digit is got this pointer to a thing. I digit is 0, so we run the next one, and then this digit is now 9, and I guess power happens. Oh yes, we're going into the standard library. Yes, let's go. Standard library stuff. So man, I don't want to read all this stuff. So I'm gonna press this up arrow, just to I'm gonna trust the C++ guys to know what they're doing. And then finally, it says, well, this is all just return 9, and then the result comes, and then now it's gonna print it. So I think it printed this. So there's two ways to debug it. One of them is print lining, which is just to print this stuff. Another way is just to, go through it step by step. So you can, if you're bored or you don't want to wait anymore, or you have a further breakpoint further ahead, what you can do is just press this play button that will go all the way to the next breakpoint. So I'm just gonna press play, just to continue execution. And now it has stopped here. So I guess I could just press play multiple times. And then this LLDB is this wonderful tool that lets you debug the program. So this LLDB guy, it has a feature where you can debug programs. So what it has is a bunch of one-letter commands. And essentially what those commands allow you to do is to check out the values of certain variables in the stack, or the local variables, to stop the program, restart the program, go set up a breakpoint, go to a certain, this is the most common command I think, go to the next command, and to the next, so I think I've seen people just to basically sit here and say, okay, n, kind of like that. And there are videos online that explain how to use LLDB in detail, so I'm not gonna spend too much time on this, but as I understand it, it's a really powerful tool that not a lot of people take full advantage of because of these modern, debugging environments. So the key idea here is that the Xcode is really making my life easy because he's giving me debugging, and I can know if I made a mistake, and the error messages are integrated into the editor, and it's just the best thing you can be using for testing out all this stuff. So with that in mind, I think this software is correct. So the next step will be to submit it to the excercism website. I will leave that as an exercise for the reader. So the next exercise in the calendar appears to be the okay, resistor color. Okay, so I'm not gonna solve any of these exercises, I just want to discuss them. So in this exercise, what they're saying is that there is a bunch of resistors, and the resistors, they have different colors, and what they expect you to do is that you find the numerical value of the associated particular color band and to list all the colors. So essentially what they're expecting you to learn is how to make arrays or make maps. And we can even, how to say, it's a really simple exercise. It's like you can do a for loop, or have a, like an array or something like that, or a hash map. So hash maps in C++, they used to be really hard to use, but it turns out that now they are super easy to use. So what you do is that you include map, and then you map a string to an int. So okay, so what's a hash map? So hash map is it's a associative function that maps a data type to another data type. most commonly the key is a string, and most commonly the value is a string, although in this example it's an int. So in languages which are interpreted, usually the map has to be absolutely has to be a string. And more recently, I believe that the JavaScript has gained a new data type, which is the map. This is like a new thing, well, new-ish. And it turns out you can now create maps in JavaScript and then map a string to a thing, and then like you can get the thing, you can put the thing in, get the thing out. It's kind of like drawers, but the new thing about it in JavaScript is now this type can be anything. It doesn't have to be something that has to have a specific string representation, and you can now map an object to a thing, and that was there in other languages, but most of the languages they just convert whatever it is to a string representation. And the reason maps are cool is because they're using this very weird algorithm where they convert the key to a number, and the number is a small and is the hashing function is supposed to have a low collision, so they're not perfect. So in JavaScript they're called maps, in Python they're called dictionaries, in PHP of all things they're called arrays, and you just use arrays and maps interchangeably. In JavaScript you can kind of do that, but here back to the C++ idea. The C++ now supports hash maps. Where did I put that? Sorry, let's just find it again. Hashmap C++. Was it this one? Okay. Oh, good, there it is. So when you create the hash map, you just define the type, you create the hash map name, you can put stuff in it, you can figure out if something is there or not, and this different to end is just some legacy 2011 iterator syntax, where all the iterators in the standard library in C++ they have a begin and an end and a find function. So array has it, linked list has it, and they all have it. So here's just telling it, okay, like, do you have this? And then they go, yeah, I have it. And they go, okay, awesome. So if you have it, you can print this thing, and I guess if you don't have it, it's not available. This is the iterator so I was talking about earlier, and here you just have to check if it's a thing or not. And when you get the thing, what you get is an iterator, and the iterator has a key and a value, and this is a generic data type. So the string is the type of the key, and the int is the type of the value. So this will be a string, this will be an int. So maybe you need the hash map to solve the problem, maybe you don't. That's fine, it's not a big issue. But I've seen solutions in other languages to these problems. It's like super 10, it's like an if statement with 10 items on it. It's super simple. It's really just to check if you can actually write in the code or not. So the next issue, isogram. Determine if a word or phrase is an isogram. So isograms. A word or phrase without a repeating letter. Spaces and hyphens are allowed to appear multiple times. Well, that doesn't look so difficult now, does it? So I think that the problem here is essentially to check if something has happened or not. And the hash map comes to mind as one solution for this. And I guess if we have 26 letters, then we could theoretically make an array with 26 things on it. And then every time there's a character, we can just, get the ASCII character of the letter and then put the letter. If we have seen this letter before, then we set the 1 out of 26. But this approach is not very international. It doesn't support uppercase, lowercase, weird symbols, Japanese. So I think it would be better just to use the hash map, and whatever ASCII character or Unicode character is coming in, we just use that. So the there is a function that converts an array to an object, and I think I wrote it recently. So let me see if I can find it. Let's go and check it out. Is it this one? Oh, it's not there. Oh goodness. Well, in that case, maybe I'm lucky and I can find it here. Did I find... Oh. Maybe I should just restrict my search to JavaScript. Oh my god, there is no JavaScript? Wow, that's amazing. So maybe JS? Okay, so it looks like I don't have it. Sorry guys. You know, I'm just super surprised that I don't have it, because I could have swear we wrote this function recently for a project. Let's see if we can find it here. Is it A2? Aha, cool. So, right, so this function is nothing super fancy or super fantastic here. It's a very basic function. And what it does is that this function converts a JavaScript array to a JavaScript object. Okay, so in this example, the keys are equals to the values. So let's see if we can interact with this function a little bit to kind of understand why it's useful and how would I even use that in the first place. So here, I'm just gonna go ahead and copy paste this function. Oh, it doesn't like it, the syntax problem. Goodness, is it a syntax issue? Well, I guess. Okay, why is this even here? Oh my goodness. Okay, so I guess I'll have to complain to somebody about this. Let's go. Cool. So the function array to object, it takes an array and converts it to an object. So let's say you have an array that has these elements such as A, B, and C. So we're gonna call this array A. Now you can use let, you can use var. I live in the past, so I use var, so don't judge me. You guys should use let. Now here, if I take an object which I'm gonna call, the map, and I'm gonna say, well, array to object, please call this function. What happens is that the map now contains an array where the key is equal to the value and the value is equal to the value. Now some of you might say, well, Felipe, that's stupid. Why would you even need that? That's like, why? Like, we don't need that, right? Well, converting the array to an object is a O(n) operation, meaning it will take proportionally as long as however many elements are on the array. However, checking if an element exists in the array, it's an O(1) operation, thanks to the magic of hashmaps now. So yes, I am paying a little bit of complexity, and I am paying with O(n) for this algorithm, but what I'm getting in return is that I get O(1) performance. Now, O(1) might be much better, because usually these lists are small, but the bigger problem is when you have a big list coming your way, which is like a million things. So if we're gonna check a million things and it's O(n), then that's a million times a million, maybe like a billion. It converts a 1000 problem into a 1 million problem. You don't want those problems. But if you have this O1 lookup, then actually this 1 million thing is doable, because doing a million things is possible. Doing a billion things or like a trillion things is much harder. So this function is really useful, and I keep writing it and rewriting it and rewriting it every time. In every new programming language, I always rewrite it again. So back in the PHP days, I think if I remember correctly, what is it here? Maybe is it here? Maybe include. No, not include. Yeah, maybe common. So back in the PHP days, it would look like this, right? So, and it's already old by this 10 years ago function. So what it does is that, well, you take an array, you make an object, and I mean PHP, so you check for the parameters being correct. Now you, for each one of the elements in the array, the keys and the values, then the value now becomes the value, the key gets ignored, and then we return the new thing. So really simple function, but it can help us solve problems like the ones that is presented to us here. So it's telling us, well, there is an isogram. So maybe it will be useful to have a function that calculates the length of an object. So if you have an object here that has keys and values, and this object is something like this, having an objects don't have length, so that really sucks. But it will be useful to have a length operator. So let's just write this length operator. So let's just say we have a function length, takes a parameter, an object, and then we can say, well, var x equals 0, and then for var I in I guess the object, then we just say x was plus, and then finally return x. Now, because I wrote this length operator, then I can apply the length operator on my little object, and I get the length of an object. So in my opinion, the way you write this function, like I guess here, is that you just take the thing, split it into letters, and then you check if the object is in fact the same size as the array. If the object is the same size as the array, that means that there is no repetition. So let's import our little function here. What's the function? Where is it? Is it here? No, not here. Maybe here. Okay, so just gonna just join all the lines so I can import it. Okay, cool. So let's say we have some inputs, and sure enough, this is the input. And now let's say we want to check if this function is in fact a isogram, or as they call it. So first of all, I will just take this a guy. I will just say replace. Like you can just replace the things like the space, or the the dashes. And if it's a space or a hash, then you just replace that with like nothing. And that gives me a new string. And now if I have this new string, I can take the object array to object of the new string, and that gives me an object. And I can apply the length operator on this object, and that gives me the length of the unique letters. And now I can check if the length of this thing is in fact equal to the length of the string. And it turns out I can use my operator in a string as well, although you can use ns@length, or you can use the length ns. I think ns@length will be more efficient, so we use this one, but just making a point that this one also works in I'm making a point that this length operator here also works on arrays. So after this is done, we can test it. So let's try ISO. Let's try ABC. It says it's true. Okay, what about ABA? It says it's false. That's all the convincing I need. Now we can, I guess, try these examples of isograms. You know, just to make sure, just to kind of make sure, you know. So 6-year-old, is this good? Well, the word isograms is not an isogram, or is it not? Then let's try this one. Well, it turns out it worked. Huh. So I guess I was lucky. So here it is, you know, very short, very compact. So, well, how do you go about the process of converting this into a C++ program? So we have to write this in C++, write this guy in C++, and then write this one in C++. So as you can see, quite an interesting little challenge there, right? So let's just go ahead and make a new project. I'm gonna call it excercism isogram. Is it? And then maybe go up one level here, open level, new folder, excercism isogram. All right, let's go. So here we are, just the standard blank C++ project. So what I'm gonna do is I'm just gonna copy paste my code. I'm gonna copy paste this guy, and then copy paste this guy, and I think we're done. So sure enough, large amount of C++ errors, but like I will not be deterred by the fact that basically 90% of my code is all red. I'm just gonna ignore that fact for now, and just focus on the actions. So first I'm gonna just kind of like format it better, because all these one-line functions, they're not cutting it. We want this code to be nicely formatted. Yes, much better. And I guess instead of our function, then maybe we should just, so we already know from earlier in the video that the word function we shouldn't use. Instead, we should use the return type. So I guess is ISO maybe returns bool, and I suppose that A2O returns like a std map that maps a string to, I guess in this case it will be like a char, right? Like it will be like a character. And this length function, I'm not even sure we need this if map supports length. So let's see, std map length. Do we have map length? Turns out that, well, actually yes. So map has length. Well, map has length. That's awesome. I don't need this code, so I'm just gonna go ahead and boop, remove it. I don't need that guy. Like, why will I need him? All right. Now this function A2Object. Let's just keep it with the same name for now. So this guy is gonna return a map. So I guess this is gonna be my data type. Oh no, I guess I need to include this map thingy here. And here, this is the map data type. So we're just gonna go ahead and return this. So this std map maps char to int. We're just gonna map. I guess on the left hand side we have a char, and on the right hand side we have a char. So we're just gonna map char to char. I think that's fair. Now, is this function gonna be useful for other problems? No. Can we make it useful for other problems? Yes, we can. So in C++, there is something called template metaprogramming. And then you can write templates where you just say, well, actually make this thing useful for any data type. And then you just take as a parameter the data type. So the data type becomes like a parameter here. And then you can make templates And I mean, this template metaprogramming thing is super fancy, but it allows you to, like, you know, like have a struct that has a abstract data type, or have a function that takes a pointer to a data type, and then you can do everything in terms of t. It doesn't have to be char, right? It can be like, you can in fact use other types, but for the purposes of my problem, I'm not gonna go into that, but it's possible to write generic code, right? So this I guess this is like an array of characters. So I believe in C++ that's called a Std String. And if you're gonna do that, I suppose we're gonna need this string in here. So here I'm making a map. So I suppose all we do is we just copy this thing and then we just kind of paste it here. And I suppose this is how you define it. But we can always, like, you know, check. So it looks like we're doing it right. So here this is var x equals 0, x is less than length, x plus plus. So here we're iterating over a string. We know from the previous example how to do that. So, but I already forgot. So I'm going to refer to my previous example. I think it was the desktop. And there was like this Armstrong thing where we were iterating over the thing. So it kind of looks like this. So I'm just going to lazily copy paste this. So here we're iterating over all the chars of a string. So we're iterating over a. And this is a char digit, so I guess just call it, yeah, just, I guess, character, item, element, item. This function is so generic, you don't know what to call stuff, right? So here, I guess, we're mapping the thing to be the key and the thing to be the value. And finally, we return an object. Okay, so, but you know, we call it an object, but it's really a map, so I don't think that's fair. I think we should call it the map. So but it's a map of characters, so I guess we can call it character map, and I think that'll be a more fair name for it. Now this a, I don't think that's good. That's a good name for a. Maybe it should be like a string, input string. Yeah, I think that'll be more fair. Now, the is ISO here function. Okay, so it doesn't like it. It's okay, so I guess I need to just rename this. Right, so maybe this works. We'll test it out in a bit. So moving on, function is ISO. So here the function is going to return either true or false, so we know that to be bool. And is ISO is going to be taking a string, so let's just call it input string, just like we call this one, because why not? And I suppose that's going to be Std String. And here we have the string without spaces, so we're just going to remove the space and the dashes. And I guess we don't know how to do that, so let's go C++ replace string. Replace character in Std String. And the reason I search Std String is because, like, C++ has Std strings and Q strings and Windows strings and standard const char star pointers, and it's a beautiful mess full of complexity, and I want to be explicit when I'm asking Google what I want. So here it turns out that, well, let's just see the examples. So you have a string, another string, and you can str replace. And there are some numbers I need to give in. Oh my goodness. So str begin, that sounds like an iterator from C++. I guess 03. So yeah, we want that. So using iterators sounds like what we want. From the beginning to the end. And then, but like, this is not quite what I want, is it? Because it's not really replacing one string with another. So let's just use another word for it. Let's try str replace in C++ std string. Now I'm searching for str replace because in PHP this is what it's called. Always come back to this. Use the language you know to learn a new language. So here they're telling you, look, there is a function replace. You just copy paste this code. It uses iterators. Replace all looks like this. And I'm gonna go ahead and say, oh my goodness. Oh, this one looks pretty cool. Oh, this is amazing. Look, we can use regular expressions to include regex, do the thing, and then we take a regex, and I mean, that's amazing. I didn't even know this was so easy. Let's go, let's try it out. So, wait, that's not the right project. Okay, so let's just go ahead and just do this, and then I guess copy paste this one, and string, yeah, Std String hello name, and then string equals whatever. So here we're just gonna try to kind of replicate this. So I guess this ns is gonna be started from input string, and now here I'm gonna have this ns to be equal to the std replace of the input string, where I don't think I need this line, to be honest, but maybe I can just do it like this, I think. Yeah, but I think it's better if we just initialize it separately. Std regex, and then here I believe my regex was just gonna be just a space or a dash. Now, it is entirely possible that this syntax is bad. So how do we know this syntax is gonna be good? Well, what I will probably do it will be like a like C++ regex online. Yeah, some online thing where I can just, you know, try out multiple examples online and see if there is in fact a thing we can use. So regex online. Oh no, internet is failing. Oh well, I guess we're just gonna have to just keep going then. So this a20 takes as a parameter the new string, and then we want the length operator, and we know this to be size, and this ns.length, then I suppose this is not a thing anymore. This input string that length, that's just gonna be input string that length with parentheses on it. And here we're gonna test it out, so we're just gonna run the iso. So let's try isograms, and then the iso, we're gonna pass in isograms std. Maybe this works. It's complaining about redefinition. It is. Oh goodness. Well, complaining is gone, so let's try hit play. We expect these isograms to be false, so it is returning 0. Well, so let us try then other strings from the exercise. I believe we have these 4 guys, so we're gonna copy paste those, and then we're gonna copy paste them here, and now we have to make this line from these guys here. So the way, well, one way of doing it will be the right way to do it. It will be just to do an array and then iterate over array. But that's not fun, is it? So what I do is I just do this instead, where I just lazily, you know, use Pim to auto-generate the code for me. And it doesn't like it because I guess I forgot to do the dot star at the beginning, so apologies. Not the best. Oh wait. So yeah, I think for me it's important for things to always line up. I think that's very important for me. So we shall see if this even works or not. Okay, so isograms is not, and then the other ones are, and then 6-year-old isn't. So I guess this part with the dash on it is not working. So I guess if we simplify the regular expression, is it gonna work? 6-year-old is not working. Well, that's interesting that it's not working, because we can see how to debug this thing. So I will, first of all, I will just figure out, like, is this replacing even working? And I think that's very important. Oh, C out. Did you mean std out? Did I mean std out? Of course I meant std out. Why would I not mean that? Okay, so let's go. Isograms, lumberjacks, background. Okay, so ns is not like printing like a string, is it? It is not a string. So I'm kind of confused now. Wasn't ns supposed to be a string? So, I mean, what's the type of ns? So let's try, I mean, ns is definitely a string, right? So let's try the step-by-step debugging. I'm gonna just put a stop break here and just press play. Okay, so here we are. Isograms is isograms, ns is an empty string. So we move on to the next step. Then replace is supposed to happen. And now here, isograms is, okay, so the ns is the same. Okay, so I'm gonna try just get out of this function, move on to the next case. Just gonna press play, and then lumberjacks play, background play, downstream play, 6 0. Okay, this is the case I'm interested in. So let's go into the function. Here it says ns is 6-year-old. So this line is perfect. It's doing exactly what we want. And I guess so. Either the problem is here, or the problem is here. So we can print both, and then we can see you know, which one is it. So let's try and check it out. I'm gonna press play, and then I'm just gonna ignore the cases where I know it's working. So isograms, I guess, press play, lumberjacks play, background yes, downstream yes, 6-year-old. Okay, here we are. So we're gonna go very slowly now. So ns std string regex whatever, and then press play here, and it's gonna print the value. So we can go up one level. Okay, so it has printed 10 and 12 because we're checking string length. Oh, we're not supposed to check that. If you remember the original code, we were not checking the original string. We're checking ns length. So I made a mistake, you know, when I was porting it. What an idiot. Okay, well then, I guess we should just change this guy to ns. And it's all my fault for using shit variable names in the first place. So let's try run it. Okay, so this is 0 1 1 1 1. That's kind of what I expected, right? And I think, yeah, we can like just comment out this line maybe just to have it be shorter output, right? So again, the process is write a little bit of code in any language you feel familiar with, make sure it works, and then copy paste it into your favorite new programming language, and then see all the errors happen and just accept them mentally. Then slowly, one by one, just change all the errors into working code, and learn new things in the process. So I think that is essentially what this process is all about, just learning awesome new features of the language. I feel so happy I'm learning new things. You have no idea. I had no idea regex was so easy. So I guess maybe we can just try, just adapt it, just maybe just to this thing where we just make sure this is gonna work again. Because we changed this, but that was not the problem. So yeah, okay, yeah, that's a little better. Right. Okay. So next problem. Having. Okay, let's see what this even looks like. calculate the Hamming distance between two DNA strings. Okay, so da 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 da. Right, so yeah, so I think this exercise is basically a string manipulation, and just like there is a very specific way. So okay, so let's. I'm thinking about another problem, which is RNA to DNA conversion. So there is another problem here, which is RNA to DNA, which is a really like an easy program. I guess maybe it used to exist, and RNA transcription, right? So this RNA is like a super easy problem where you have a thing and you're supposed to map on everything. So I was just gonna discount it as just an easy problem, but actually no. Oh, by the way, this one is really cool too. You should try this one also. Anyway, so let's just try to read this carefully. Calculate the Hamming distance between two DNA strands. So the body is made up of cells that contain DNA. Those cells regularly wear out and need replacing, which they achieve by dividing into daughter cells. In fact, the average human body experiences 10 quadrillion divisions in a lifetime. When cells divide, their DNA replicates. Sometimes during the process, mistakes happen, DNA gets encoded in correct formation. If we compare two DNA strands and count the differences between them, we can see how many mistakes occur. This causes a Hamming distance. Read DNA, using this you can see AGT, and two strands might look like this. So this one is same, this one is different, this one is same, this one is different. So I guess difference is just this guy here. I'm just checking. Yeah, okay. So whenever there is a difference, they have 7 differences. Hamming distance is 7. Well, I mean, this is just dumb. Like, we can code this shit in 5 seconds. So basically, we can take a function that takes a Hamming, that takes 2 strings A and B, and then we can say for bar x in A, then we have the index, so we have x, I guess ax. If ax is different, if ax is equals to bx, then that's gonna be a thing. But if it's not true, if ax is different from bx, sorry, computer shut off. Okay, turn back on. So if this is different, then I guess we use distance plus plus, and we need a distance guy. So let's just go ahead and say bar d equals 0, and then finally we return d. And no, I don't write all my code in one single line all the time. It's just that these exercises, they're just dumb. So let's try unexpected token identifier. Oh my god, made a mistake. That's not good. Now it's a one line of code thing. Maybe here, I guess this is where I did it. Oh, it doesn't like it either. Maybe extra parentheses here that didn't need to be there. Maybe. No, still doesn't like it. Oh yeah, because now it's this was actually not supposed to be removed. No, still doesn't like it. Okay, so maybe it's not supposed to be function, but instead function. That's a bit better. Alright, so let's try Hamming of, let's try AAA and AAB. Distance is 1. Distance is 2. Distance is 3. Yeah, I guess maybe if the strings have a different length, that's gonna completely explode. So if I give it strings different length, that should not even try to happen. The JavaScript is gonna accept it. So I'm just gonna start like from the beginning, like if a dot length is different than b dot length. Well, in that case, I'm just gonna go ahead and say, well, end it. Just return, because like we cannot even try to go find strings with different lengths. And I think that would be a better answer. So right, raising an exception. Okay, so I was supposed to raise an exception. Sure, let's raise an exception. Let's just throw some bad thing. Maybe you're supposed to say here new exception. I think this is how you do it in JavaScript. I think this is how you do it. I don't really remember. I don't use exceptions. I think they're stupid. expected expression, return throw. All right, yeah, it's supposed to return throw. Yeah, so I think maybe if we try hamming of this thing, this throws an exception. Exception is not defined. Well, that is an exception, so okay, let's Google it. How to throw exceptions in JavaScript. All right, so yeah, you can throw anything. It's called error, not exception. Okay, so apologies. So let's just call it error. Good. So is it working? No, it's not working. Okay, error message can improve. Right. So how do we convert this thing to C++? Well, I'm not doing it. There, I'm just not gonna do it. I'm gonna leave that to you guys. You guys have to do it. And then once you write it, then you can send me how you did it. I'll be happy to evaluate any code you send my way. And if you want to send it, you can just send it to this email. We're gonna put in here. We're gonna send it to felipevaldez@gmail.com. So you want code review, feel free to send this to me. This offer is only valid for 365 days. After that, no code will be reviewed, and I'm not gonna feel bad about it because I set a time limit. So I hope you watch this video in time. I hope this is at all useful to you to understand what my process is for migrating from one language to another, where a language might be unfamiliar, and maybe you don't know exactly how to do the thing. And that's fine, you know, it's okay not to know things. It's okay that you need to Google things. This is really part of the everyday process. So the important thing is that even if the code is completely red and everything is completely messed up and, you know, effed up beyond recognition, we continue anyway. And we try until the program works. So with that, I think, what's the next one? Grains. Right. So this one I will leave for the next video. And I hope this information is useful to you. Thank you for your attention today.